Yes, sir, it is live now.
Okay, okay. Just we'll wait some more time. See, Nirmiti Kendra engineers all duty bit partharagiದ್ದಾರೆ. Project director.
Hello, good evening, Babu. Can you hear
Good
me?
evening. How are you, Rangnath?
Fine, fine. Will it be okay? This will be.
I'm not able to see your video. I'm not able to.
I'll.
Yeah.
Will it be okay? Just I wanted to test because tomorrow it should not become a problem, na? That's why.
Yes, sir is working as a professor in Oman, sir.
Hello, sir.
Thippeswamy, sir.
Namaskara.
He's
Namaskara, sir. Namaskara.
He's from Tumkur, my classmate in PUC.
Oh, very good, very good. Yeah.
Tomorrow is his lecturer. He's expert in precursor concrete techniques.
Okay.
Now it is a part of.
So I want to listen to your this one also, sir. I want to listen wastewater management technologies. I want to listen to you.
I think not just because I am waterman, but at the same time, water has the highest importance in the whole world now. Not necessarily in India. Of course, highest in India, but not only in India, but all over the world.
Sir, without water, life would not have been there. There is no life. There is no life without water.
But things are getting strained, and in the sense, scarcity has creeped in because of the so many factors. I think let us discuss it more in detail. I think basically three things in our opinion. One is population growth, urbanization, climate change, and these are all creating a more and more
putting for recording.
Yeah.
Babu, I'll take leave. I'll be here.
No issue.
Sir, you can start, sir.
Yeah.
Can we start?
Yeah. Just I will introduce 1 minute, sir. Just 1 minute. So good evening to all present here. I'm happy to welcome all the participants for a 43rd lecture series of upskilling programs for the Nirmiti Kendra engineers and other engineers of the PWD, other CMT trainers also. The upskilling program on construction management and techniques that has been scheduled. This is the 43rd lectures. Today we have an eminent speaker of the 6 decades of experience, Engineer Thippeswamy sir. He is going to share a lot of input on 2 topics on water management technologies and how to generate a revenue from the wastewater management. I'm happy to welcome all the participants for this program, online program. We conducted online, offline as a blended mode to benefit the Nirmiti Kendra engineers. There are 20 engineers are registered for this program, and I hope all are going to take part this seriously. And just is a very important topic what we scheduled today. It is a part and parcel of our life. Water is very, very important commodity because how to save, recycle, reuse concepts and how to make a revenue generation with respect to wastewater also. I welcome once again all the participants, and also I'm very happy and honored to welcome today's speaker of the day, Engineer Thippeswamy sir. I'm very happy, sir, and also on behalf of the Skill Center, on behalf of director and all the participants and my own, I welcome you wholeheartedly. And also I'm very thankful to you, sir, for giving me an opportunity, all of us to listen from your experience, 6 decades of experience on water and wastewater management techniques. We are very much honored to have you today, sir, and welcome on behalf of everybody. I welcome you, sir. And also welcome all the participants and project directors, Nirmiti Kendra engineers, and also CMTI, Construction Management Training Institute also. And also I welcome Professor TVL Rangnath, joined from Oman, tomorrow's speaker. He is also available. I welcome Rangnath TVL from Oman. And also welcome all the participants who are all shown a lot of interest to learn many things from this topic. I welcome all of you. And also I welcome Director Srinivasa Kulkarni and all the other board members of the Skill Center. Welcome you one and all for this guest lecture. And also before going to this the topic, brief introduction about today's speaker, Engineer Thippeswamy sir. He is having almost 6 decades of experience in the water and wastewater technology management, and also a leading consultant. He is retired from BWSSB as a chief engineer, super time and engineering in chief. And currently is doing a lot of national, international consultant with respect to water and wastewater management. Sir is having a bachelor degree in civil engineering and master degree in environmental engineering. Sir has born in Chalkere town, Chitradurga districts. Lot of professional experience. Just I have shared all total resume to all the participants just for the benefit of the few members of the other board officials. I will introduce the engineer Thippeswamy sir. Worked as a BWSSB for 34.5 years and retired as a chief engineer super time. After the retirement, working as a freelance the consultant for both public and private institutions for the last 17 years. So after retirement, I'm very happy to note that 17 years you are very active in professionally, both the national and international level. And also I'm very happy to note this, sir. During his career, BWSSB apart from working in operation and maintenance of water sewerage system, introduced highly innovative projects in wastewater reuse, ICT in water and wastewater sectors such as SCADA, telemetry, GIS, application of IT sections. And also, sir is responsible for the first international funding to BWSSB from OECF, Overseas Economic Cooperation Fund, which is renamed as a JICA now for the implementation of Kaveri Water Supply Scheme 4th phase at the phase 1 for rupees 1,542 crores, and later CWSS 4th phase and the rupees 3,600 crores to bring 270 million liters depth and 5 MLD water respectively from the river Kaveri. And also, sir is responsible for bilateral funding from France and local HUDCO for supplementary funds implementing wastewater recycling plants, 60 and 10 MLD plants at V Valley and Yelahanka respectively in 1994 itself. That means sir has developed a first municipal recycling plants in the country itself. Very happy, sir. Congratulations for this achievement. And also preparation of GIS with a French company for the first time in water sector in India, purchased equipments for leak detection of underground pipelines leakages from France. Sir also responsible for preparation of master plan for water, sewage, stormwater, solid waste for next 25 years, 2025 with the bilateral funding from Australia, with 90% funds from Australia and rest by BWSSB in the form of manpower and accommodation. Worked as a project director for 2.5 years in the preparation of 35 documents, and also responsible for conduct of energy audit in Kaveri project CWSS 1 and 2 pumps and saving rupees 11 crore every year for replacing highly efficient premium pumps, and also got a national award. Congratulations, sir. Responsible for preparing documents for PPP project report for Kaveri water supply scheme 4th phase and 2nd phase under the boot concept, build, operate and transfer, build, own, operate and transfer, and inviting tenders, calling pre-bid evaluation and bids, etc. And also responsible for obtaining funds from National River Conservation Project of rupees 60 crores grants for interception and diversion, rehabilitation and improving sewerage systems in the city. Responsible for inviting tenders for 50 MLD wastewater recycling plant in Koramangala and Chalagatta Valley evaluation as tenders. Responsible for introduction of water safety plan in BWSSB in 2 pilot areas of wards of 92 and 93 of BBMP through environmental management policy research. Worked as an advisor for implementing French funded projects in Visakhapatnam and Andhra Pradesh just in 1997 and 98 while service in BWSB. Worked as an advisor for implementing 1 MLD recycling project, Bangalore Golf Club. Worked as a chairman of technical committee for Lake Development Authority 2002 to 2005. Worked as an advisor for IAC, Indian Institute of Science, for preparation of GIS, UFW, recycling of wastewater for non-profitable purpose and design and implementation of ring-bin supply recycled water. And also, sir, as a worked as an advisor for Aragam for the integrated urban water management of Mulbaglu town, advisor for German technology research, GTZ, and also we're now working as a faculty for many institutions like IIHS, ESCI, LNT, SUID, ASCI, ICAP, and many more training centers. Sir also a doctoral committee member for many of the students doing PhD and his guidance. Just to mention few, he has guided a topic on potential of distributed recycled water to reduce the overall energy intensity of urban water and wastewater system for effective water services in Bangalore. Sir is also a lot of professional membership, member of International Water Association UK, and also the member of Indian Water Works. See, like that, many professional bodies, sir is actively participating. I'm very happy to note, sir, and also involved in many projects. Just because of the time constraint, I don't want to take much time. I am going to share the complete the bio sketch of the engineer Thippeswamy for his excellent professional achievement both in the government and currently is doing a lot of consultancy in the area of water and wastewater management. Thank you very much, sir. I'm very happy for accepting our invitation and being with us today. And you are going to share a lot of information. I request all the participants to interact at the end of the session. Sir is going to give 45 minutes first slot, then there is a video presentation, and there is a second slot. So all the questions I request to post in the chat box, we will take up at the end. So now time is yours, sir.
Sir, please unmute, sir.
I will come once again for the those who join late for this special guest lecture.
Thippeswamy, sir, please unmute, sir.
Hello. Sir is audible?
He has to unmute, sir. He's there, he has to unmute.
Just check with sir what happened. Hello, can I call?
Yes, sir, please. Ask him to unmute, sir. He's there.
Now it is unmuted. Now,
yes, sir. Yes, sir. Please go ahead, sir.
Now, shall I say okay now in this?
Yes, sir.
Yes, sir. Please
I
go ahead.
welcome Engineer Thippeswamy sir to take over the sessions and present the first slide.
Yeah, I think now everything is set, is it?
Yes, sir.
Okay. Good evening to everybody. First, everybody who are on the video and listening me. First of all, it's my endeavor to thank the organizers, particularly Dr. Venkatesh Babu, the central and head of Bharat Ratna Saramvi National Training Facility of Skills for All, and Srinivas Rao, the Srinivas Kulkarni, director for giving this opportunity to share the thoughts on wastewater management and technologies. And to start with, I will be speaking about an hour on the technology, technologies that are available, and then I will show you the video. Then next one will be on the issue of recovery and resources, which is very, very important in this present context, not only in India but all over the world. So with this, I start my presentation. So My format of presentation will be basically to start with why wastewater is also named as a black gold. So what is the scenario of wastewater treatment in India and abroad? Treatment technologies in basically what is fecal sludge management in peri-urban area and how it is being treated. Different types of technology in treating municipal wastewater and industrial wastewater. And then what is circular economy? How this can be applied to water. So untapped resources of wastewater. So recovery of water, energy and phosphorus from from wastewater. And case studies of in India, USA, Singapore and other countries. I think I have just generally given you the gist of my presentation. We will start with what is in this context it is necessary to understand what is the scenario of water, because water and wastewater go together. Without water there cannot be a wastewater. I think in that context I have a few slides I will show you what is the scenario of water in not only in India but all over the world. What is the scenario and how, in order to make good of this freshwater resource, how this wastewater can help us. I think that is the most important part of the whole exercise, which is being dealt all over the world in this context. So let us understand, when Mahatma Gandhi, as early as 1925, has stated sanitation is more important than independence. I think you can understand how important is sanitation. I think sanitation covers not only water but also wastewater and the solid waste. These are the three important components of sanitation, and which is really in a poor state of affairs in Indian scenario. So water is called as liquid gold. I think without water, perhaps you are aware that nothing can exist, particularly living beings. I think water plays a very vital role. In this context, fresh water is more important because of the fact that we need fresh water for basically for most important issues like agriculture, industry and drinking water. So in this forum, when once is called liquid gold, black water, wastewater is called black gold. I think that is the scenario. I think you are well aware of what I think the scenario of water scenario. This is a latest report, latest slide which was produced by Water Resource Institute, where you can see the dark red colors. Most of the places they are in a very vulnerable scenario. Look at the baseline of water stress. If you look at any country, I think India's scenario is very, very bad. I think that is what exactly I would like to state. When water is not available, I think wastewater generation also will be reduced. I think in that context, we have to really, of course, it is nothing. Even in USA, if you look at southern USA, also they are in the tremendous scenario. I think the shortage of water. I think look at China. There is also every country. I think even the southern part of Europe is also facing tremendous water shortage. So with this, I think why I am telling this water without water, I think there cannot be any other economic this thing and living conditions. So with this, I think what is we are thinking of is this is another slide which will show you between China and India what is it, how this the precipitation happens and what is the population that is being served. China gets about 7% of the world's freshwater resource, whereas India gets only 4%. For a population of 18%, today it is mentioned here as 17%. It is almost 18% now, and China is almost 7% with 20%. 20% of the population in the world. Today we are almost in the 7.8 billion people in the world. I think India is 1.3 billion already. I think 18%. I think 4% is very small when compared to the extent of population that we have. So this is something what we have to seriously look at, and how best we can conserve this water and effectively utilize this water is most important. At the same time, if you look at here, this is a scenario of 625 million people are defecating outside. This is a bad sanitation of the whole thing. Whereas China is 14 million, We are 626 million. This is a report from World Bank that as well as 2015. But things have slightly changed, but it's not dramatically changed. I think this is something what we have to really look at. So coming back, what is the scenario of the world scenario on water? I think rivers are running dry. See, many major rivers, including Colorado. Colorado is famous river in North America. And the Colorado River is today almost 50% of the water is not there. You must have heard, the famous Hoover Dam, which was supplying almost to many of the adjoining cities of water supply and producing about 2,000 megawatt of power. But today's scenario is almost very critical. Not even 50% of the water is available in that. Similarly, in Indian scenario, Ganges and the Indus, Rio de Janeiro in Brazil and Yellow in China are so overtapped that they're now running dry for part of the year. Almost 1/3 or 1/5 of the year, they are running dry. So now second important thing is in this water, after the surface water, groundwater table is falling every continent. Aquifer, in fact, India is the worst among all the countries in the world. So aquifer depletion is now a new problem. Water tables are falling from over pumping of groundwater in large portion of China, India, Iran, Mexico, etc., etc. I think this overdraft, annual groundwater overdraft, and nation whole world is suffering from this overdrafting. In current scenario in India, rising population, urbanization, climate change, and industrialization has led to an almost unmanageable of wastewater problem in India. This is leading to a toxic contamination of our water sources. We must find a solution to rising challenges since wastewater treatment in India is simply too important to be ignored. See, today's scenario is that we are only treating about 27 to 30% of the wastewater, but other 70% is still not being treated. So in fact, India direly needs a comprehensive national policy on wastewater management. The limited and inadequate resources we have today means that whatever resources we do have, we must utilize them wisely. Managing and treating this wastewater is just part of this. So today, the world scenario is that 70% of water is used for agriculture. If you look at this slide on the left-hand side, you can see this is the 70% of water is for agriculture. This is average, but Indian scenario is much worse because we use more water for agriculture. It is 80% plus. And we use only about 7 to 8% of industrialization, and rest is for drinking and residential usage. So the productivity of the growing economy, we need water. If there is no water, there is no manufacturing, energy production, agriculture, mining, fishing, and more and more. In fact, there are many sectors of the economy not dependent on influenced by water. I think another important this thing, if you can notice here, is that roughly in industrial sector, roughly 75% of the industrial water withdrawal are used by energy production. That means if we are 10% of 10% of water is used for industry, 75% of 10% is used for only power generation. I think this is something very scary. I think we have to reduce that usage of water. So perhaps you must have read a few years back. See, Cape Town has almost managed pushed back to day zero. Virtually, there was going to be day zero in the estimate when taps in the city could run dry. In 2019, after successful water saving efforts, they have somehow overcame this day zero. See, that probably is a scenario in India, and we have done that many occasions. But in India, day zero has come and gone for residents in many parts of the country where taps have failed long ago, and people have stunned instead of digging wells or buying water. I think I think this is the scenario, and going to be. I think you must have read in papers and so many. Simla, virtually there was no water, and so many cities in India are lacking water. So let us let us come to this real sewerage system in India. Urban areas in India are almost invariably plugged with insufficient and inefficient wastewater facilities. That means, so we don't have, as I said, I will show you some of the scenario is wastewater is not being treated. Even in Bangalore, this was only started in late in 1970s, and see, we have only provided primary seed treatment, and subsequently in 85 only we have tried to have a secondary treatment. Now things have straightened up, but over a period of time, wastewater is given a loose, in fact, what I can say, given a raw deal of not treating this wastewater. And today we are suffering for that. Resource crunch faced the municipalities and unauthorized growth of the cities, and are two major causes of this pathetic state of affairs. So this is not only in Bangalore, but also in many major cities where there was sewerage systems are there, even metros. I think scenario is now slightly changing. According to the latest estimate, only 35–40% of the urban area population is privileged having a sewerage system. This is very important to understand. So only some metros and some class 1 cities have this sewerage system, but rest of the cities still have only these sewer pits, I think, are these cesspools, etc. And we call it as septic tanks, etc. See, they hold sewer lines and which are not managed properly. Often sewer lines break down and they are overflowing, even where there is sewer system is not properly managed. Most cities do not have proper arrangements for treating the sewage waste and is drained into nearby river or in the sea. Kolkata, Chennai are this clear example, thereby polluting the water to water bodies. The most Indian cities water pipe runs in close proximity of sewers, and the leakage leads to contamination of water. This is a scenario even Bangalore. You take any city, because see, water supply line and sewer line are many places are running close by, and that during non-supply hours they are leakages happen and they are polluting the water. I think this is the latest report which was produced by Niti Aayog, where they have clearly indicated that the Niti Aayog produced reports on water. And the Niti Aayog report clearly enunciates, in India, at least 2 lakh people die every year due to lack of access to safe water. That means we don't have a quality water for drinking, but this is the scenario. I think India's water crisis is 70%. India's water contaminated. That is exactly what we have just said, because the pollution of water by various agencies, I will come to that. I think 75% of the households have drinking water to the premises, don't have the close to this their houses. 84% rural houses do not have access to piped water. 40% of the population will have no access to drinking water, and 6% GDP will be lost because of water crisis. I will show you that this also in the next slide. India's water demand is projected to be twice the available supply by 2030. I think where do you get this water? That is something what I am going to speak now about. So now proposed source of contamination are point and non-point sources. What are point sources? Point sources are basically domestic sector. If we don't treat wastewater and we take it to a point and without treatment, we are letting into the river. I think that is exactly what is happening from domestic sector, and in all industries also there's a point source. We are just leaving it to the rivers. Agriculture, this is a non-point source. Agriculture, forestry and fishing, this is again a non-point source. Runoff for rainwater, this is another non-point source. See, runoff for non-point source, storm water which precipitates on any urban area, that is going to precipitate, and that water is carried away to the rivers with so much of dust and also all sorts of pollutants in that. I think that is the non-point source. So in addition, we have also mining and quarrying from, that is the point source, and construction purpose. Also we are creating a lot of pollutants, and that is also a point source. So with this, these are the areas where we are polluting the water, the fresh water, and resulting all the rivers in the country are in a very bad shape. We have 5 important parameters, where we are classifying the rivers under A, B, C, D, E groups. None of the rivers are coming in A, B, C group. They are all either D or E, because the DO content in rivers are very low when compared to what supposed to be A, and the other parameters. So in that context, we have to seriously look at how this wastewater should not reach to the rivers and rivers become healthy. So see, pollutant different sectors in the impact of human well-being in the ecosystems are human settlement. Human settlement in the sense of residential uses. We have sewage effluent in the wastewater effluent, storm water, and solid waste. These are the type of pollutants which are getting into the water and see, increase in total and fecal coliform pathogens and persistent toxic chemicals. So this response of these drinking water, water and wastewater guidelines and standards, treatment plants, protection, restoration, development, etc., water quality monitoring should be done. So if you want to really address the problems of water coming from human settlement. Agriculture, again, coming back, your see, pesticides, herbicides, organic matter, all these fertilizers have a runoff, and they are going to prevent direct the green belts and riparian buffer strips, etc., etc., and water quality monitoring has to be done. This causes eutrophication, health issues, and harmful algal blooms, etc. So thirdly, the industry influences industry effluent, increased contamination, heavy metals, etc., and that is going to cause a build-up of pollutants. So these are all some of the import. Tourism also creates a lot of. So coming back in the catchment, let us take, for example, of Kaveri River, which is flowing in the mainstream. We are getting all sorts of organic and inorganic pollutants, both from residential urban area, wastewater from the cities and towns, etc., and also from industries. You can see in industrial district, they are discharging industries, something like that. Now today, even river, Kaveri water is also highly polluted. You can take any water in the country, any river in the country, they are highly polluted. That is, which needs a catchment management, total catchment management, so that all these things should be treated before it is let into the river. This is our main concept. I think now things are taking some shape. I think a lot of different type of funding was made available in order to intercept these things. National River Conservation Projects and the Government of India is giving a lot of money, and so many things are happening, but still it is highly inadequate. I think we have to go in a war footing. Probably Ganga is doing something. I think Ganga, they have spent a lot of more than 2,000 to 3,000 crores in the last few years, and they are installing also sewage treatment plants and also intercept and diversion of the network. So now coming back, on the issue of how this water from the domestic usage, particularly groundwater or glacier, this water which we are using, natural water, and this from even the ocean also, we are using water from the ocean, because most of the cities adjoining to the sea are having a desalination. Nearly 121 countries are having a desalination project. I think the water, one of the water resources becoming ocean sea water. So now the natural water, which is utilized by the municipal authorities, either residential usage, is used for drinking purpose after treatment, and this drinking water again goes as industrial and municipal wastewater is coming as a wastewater. This is the wastewater which you are looking at. This wastewater is almost 80% of the water utilized by the particularly domestic, commercial, and industrial usage. And this 80% of wastewater has to be recovered. Then only we can sustain water for the coming years. So how we should be treated? Treated effluent, we can have primary treatment, secondary treatment, advanced treatment. So with this now, we can also go in for repurified water. First treatment, second treatment, we can go for repurified water and going for even for drinking purpose. This has happened in many cities. I am going to touch upon that. So this is the area where wastewater has to be recovered. See, if you look at the overall world scenario, 80% of the world's water is released to environment without treatment. This is a very serious thing, and perhaps a lot of attention is SDM goals from UN. 17 goals out of this. This is one of the very important goals. More wastewater than ever is happening. I think this wastewater has to be recovered. So now coming back, see how wastewater, see after using this water, fresh water, how this, see, I told you about 70% of water is used for agriculture. See, for example, 38 plus 32 is used for agriculture consumption. Out of this agriculture consumption is only 38%. Rest of the 32% is going in the draining. I think downstream by way of seepage, etc. I think this 32% is something which we have to recover. Second important thing is on see the municipal wastewater, municipal water, which you are using average. I told you 11%, 10 to 11%. Out of this, 3% is only utilized by the public, and 8% is coming out. 80% is coming out the wastewater. I think this is exactly what we have to really utilize this water. This 32% plus 8%, 40% plus industrial water, which is 20%, 16% is coming as a wastewater. So out of this 40 plus 56% of wastewater released has to be recovered. I think that is the main purpose of today's scenario, because we don't have any other resources. Our water is availability of water is fixed. I think that is finite. You cannot add one drop of water to the universe, or one drop can be removed. See, overall scenario is we have a certain quantity of finite resource. This finite resource has to be catered to the more and more people. That is exactly what we have to seriously look at. See, look at this scenario of what is happening present sewerage system in India. We have class 1 cities, class 2 cities, and also metros. These put together, see, this is the volume of water treated. I think the volume of water not treated in these cities. I think ultimately this is the entire country scenario. Only 30% is treated. You can see that untreated is 70%, treated is only 30%. Even in this 30%, some of the plants are not functioning well, and they are not discharging what is earmarked parameters has to be maintained. So this is another. So what is the impact of all this wastewater? Impact of this wastewater, we are losing $53.8 billion US, equivalent to some 6% of our GDP, which is which means 260 billion per year we are losing. I think which is very, very serious case. And when you compare to other this thing, Philippines is 1.4 billion, Vietnam is only 780 million, Laos is only 193 million, Cambodia is only 448 million, Indonesia is 6.3 billion. Indonesia is much worse than Indonesia is a small country, 6.3 billion. So this is a report which you can read, which is released from several international companies have together along with World Bank have done. Because of inadequate sanitation. So the cost of India is 2.4 trillion rupees, equivalent to $53.8 billion is lost. That means it is equivalent to almost 3 states' budget. I think we must give a serious thought. If the government really wants to do something genuinely for improving the GDP, I think they should think of how to make good of this sanitation being made very important component of the so the coming back, the wastewater, as I already told you that only 30% of the cities have got the sewerage system. Rest of them still have only a defecation, open defecation, or a single pit. This thing, I think, dual pit and septic tanks. I think in that connection, on-site sanitation, and off-site sanitation. These are the two important. On-site sanitation is basically what we are looking at, cesspools, etc. Wastewater treatment is wastewater treatment is where sewerage system exists, and fecal stage management. Fecal stage management has to be done for on-site sanitation, and wastewater treatment for the off-site sanitation. So in the treatment process of wastewater, we have centralized wastewater treatment and decentralized wastewater treatment. Centralized wastewater after 1970s onwards, 75 onwards, we are looking only for decentralized because of the fact that instead of conveying this waste for a long distance and providing a big network of huge diameter capacity, we are looking decentralized wastewater treatment just because we can recover this water and also other byproducts. So a lot of, see, in fact, in Bangalore itself, we have almost 2,600 decentralized wastewater treatment plants provided in all the, see, most of the highly housing complexes, and also this hotel industry and corporates, and also these educational institutions. They all provided decentralized wastewater treatment plants. So ranging from 0.5 to say more than 5 MLD, up to 5 MLD. So we will come to this. I think basically what I'm trying to say, India is only 30% of cities such as metros, class 1 cities have few cities have the sewerage system. The sewerage system has two components. What I just said, sewerage system has two components. One is an sewage network or sewer pipeline network, and second is the treatment plant. This encompasses sewerage system. So rest of the 70% still don't have sewerage system. They all depend on low cost sanitation. I think, as I said, septic tanks, sanitary pits, community toilets, etc., etc. There are three types of treatment: centralized, of course, decentralized, and fecal site management, which I'm going to show you then. The metro, there are a number of decentralized wastewater treatments, and see the big housing complex, etc. And see, we also have a fecal sludge treatment plant. I think this is a scenario of fecal sludge management. This also has not gained much momentum. I think now from last 3-4 years, it is taking bigger momentum. And government of India and rest of the governments are putting a lot of sanitation sewer pits, particularly in the villages and class 1 peri-urban areas, etc. I think what it is shown in 2011 was 13.9% of wastewater system, and 36 was on-site facility, and almost 50% was defecation, open defecation. I think you can see here, this has now there is a tremendous improvement in wastewater system, because under Jawaharlal Nehru water supply schemes and Atal Bihari Vajpayee Amrut, also they have given a lot of funds, and a lot of sewage treatment plants have come up. I think I'll talk to that later, but this is the scenario. I think we have three components: wastewater sewerage system, and this is open defecation, where we have to convey this sludge from the each of the sewer pit and the septic tank and treat it to the standards. So coming back, I think this exactly show you sewer sanitation. This is the conveyance system of the sewerage network, and this is the treatment plant. I think these are the treatment plant. And in case of on-site sanitation, I think this is exactly what latrine, septic tank, where this conveyance system, I think tankers are sucking this from the cesspools and then taking to biosolids to the treatment plant, where it is. I think a lot of states have already started this fecal sludge management in a big way, particularly in Tamil Nadu. I think I was part of the advisor to that the whole thing, and they are doing a very good job. I think the whole state will be taken up. So this is a single pit plant, a septic tank, a dual pit, etc. I think perhaps this must have been already taught some time back. I think this is exactly what we have to really do: open defecation, reduce open defecation, access to sanitary latrines. Then we have to go for standard contaminant system to avoid leakages, and then we have to safe collection and transport. Exactly, this is a collection pit, and from where this truck is going to collect this the settled septic sludge, and then it will be taken to the treatment plant, and then because that treating septage and safe levels and disposal, and ultimately the reuse products that will be maybe say with the sludge and as well as the water can be utilized for economical benefit. This is another containment. I think a single pit, twin pit, conventional septic tank, urine. See, we have also you can say septic tank apart from sewage. We have black water. I mean, we have black. We call it as black water. We also got gray water. Gray water in the sense without toilet water. I think rest of the things can be collected is called a gray water. where it can be treated very effectively within, because it doesn't have more contact, more pollutants, and that can be treated. Grey water treatment is also practiced in many urban areas. I think you can see it in Bangalore. Many of the hotels are going for grey water treatment. And we can also look at, see, yellow water, just urinate water. Now things are coming up, even the sewerage and even the toilets, they are providing a separate unit for collecting say yellow water, which is having a high level of nitrate used for agriculture for various better marketing. I think, see, this is see, almost in the sewerage system, we have two important process in the biological treatment, particularly aerobic process and anaerobic process. Aerobic process is energy intensive, and see, the anaerobic process is see, it produces, it takes almost nothing of energy or minimum energy, and even produces energy during the process. I think in this process we have activated in the biological processes. This is also called suspended growth, attached growth, and submerged attached growth. These are the three different types in the aerobic process also. And in the anaerobic process also, we have suspended and attached growth. We are going to discuss those things in much detail. I think before we go into that, this is a holistic way of looking at the whole sewage treatment plant. See, sewage system, actually here we have see, low-cost wastewater treatment plants. Low-cost wastewater treatment plants, basically, they take more land. Sorry?
So please go ahead, sir. No issue, because somebody has the cross.
No issue.
Please go ahead.
Okay.
Sir. Yeah.
See, we have anaerobic, aerobic lagoons. So we have USB plants, we have facultative plants, mensuration plants, and wastewater storage treatment facilities. So these are some of the see, under before we invented see, the technologies to see, to reduce to take less area and treat it more effectively. I think there are a lot of technologies have come in from last 1.5 centuries. So in fact, activated sludge process recently they have conducted a centenary. I think this is one of the processes which was there for a very long time and still is there. And the various changes in that aerobic process, in the activated sludge process, we have several other process technologies are like step aeration, contact stabilization, and and also extended aeration, etc., etc. So now coming back, see, in providing these low-cost technologies, see, we need a large quantity, a large area of land for treating. So almost see, waste stabilization points or facultative points or say mensuration points, etc. They need almost 1 to 1.5 acres of land per every MLD of water. So this is going to be very difficult.
Sir, please unmute, sir.
Okay.
Yes, sir.
Hello.
Yes, sir. Yes, sir.
So we have in a sewage treatment plants, we have a preliminary treatment and primary treatment, secondary treatment, and advanced treatment. Advanced treatment is nothing but tertiary treatment. So these are the 4 stages of treatment in technology. I think I am going to discuss all these things in the next few minutes. I think in the primary settlement, the preliminary settlement is screens and say cutting of this thing, commuters, etc. And the primary treatment basically a physical process and where solids are made to settle. And in the secondary treatment is basically a biological process. Entire thing is a biological process, whether it is low cost process, in fact, say high activated sludge process, tickling filters, rotating biologicals. All these are all biological process. And the tertiary treatment is a combination of chemical treatment plus biological treatment. So in this now advanced technologies is the membrane technology. So I will discuss those points in what are the different type of technologies that we are providing. So generally the sewage treatment plants, these are the existing the discharge standards. Now that is the government of India is making it more stringent by way of making things much better the river quality. I think also use it for non-potable use and other users. I think if you look at here, BOD was 30 and they are now making a 10 milligram per liter. Total suspended solids, they are making a 10, and COD, BOD, etc. Nitrogen. The nitrogen phosphorus are more critical because these nowadays in the present stage that is not at all having any reckoning, but now they have reduced it to 10 milligram and ammonia nitrate with 5 milligrams fecal culture. So these standards are going to be much better if they can achieve it on a continuous basis. The quality of water getting into the river or the spring or the lake are going to be much better. So this is a conventional secondary treatment plant, as I said, that of screening followed by grit removal, primary settlement tank, and this is a biological process of variation, then secondary clarification and filtration. So this is ultimately we can leave it to the any water body and receiving stream appropriately without any. So in the process, we are going to get a lot of byproducts, the secondary sludge, primary sludge. This is very important. What we are looking at is in these sludge, this sludge is again utilized for after by feeding to the digester. We are getting a methane, almost 70%, 65 to 70% of the total gas. Out of the total gas, 65 to 70% is methane, which is very, very important for converting this into energy, or even CNG and LNG. So today CNG, it can convert this biomethane into energy, not only in terms of electricity, but also in terms of CNG and liquid. So that can, all these days we are flaring up, burning that with, and this methane is almost 38 equivalent to one unit of methane is equal to 36, because IPCC originally started in 90s and they have equivalent to methane is equal 26% of 20 units of carbon dioxide, but today it is 36%. So in that way, methane is very vulnerable to the greenhouse gas emissions, and the nitrous oxide is another one, which is 398 times equivalent to 1 unit of carbon dioxide. 1 unit of nitrous oxide is equivalent to 398% of carbon dioxide. So we are looking this, even I am going to discuss these things in the next 1 hour slide. So this gas that is stored will be converted into energy, and that energy, now today most of the energy converting this energy, almost in Chennai they are using 70% of energy generated from their own treatment plant. They are using only 30% they are getting from grid. So probably in the few days they may go in for 100%. That means that is called energy neutral. You can generate electricity by this digester, by this sludge converting into energy, and 100% of energy can be utilized for running of the entire plant. So this is another important area. The third important area is, even here co-digestion is done, and now they are generating more power than what is required. That is more than the requirement of the treating of the entire sewage. That will be put back into the grid, and they are making money. So I can show you some of the very interesting slides where many of them are making money by generating more power and putting back into the grid. So this biogas in most of the Scandinavian countries, and also in Sweden and Finland, they are running with for motors and also railway engine, and they have got so the renewable energy is used in a big way. So with this, so in the sewage treatment plant, the electricity consumption is like this. I think secondary treatment is aeration is the highest user of electricity. electricity, which is about 55%, and rest of the various other factors will be for anaerobic digestion, 14%, and see this lighting of buildings, etc. Wastewater pumping, you see, that is recycling of sludge from secondary sludge, see, back into the aeration tank, about 14 point. So this is a general tendency of usage of electricity in the activated sludge process. Now, which are the different type of, see, this is a conventional wastewater treatment systems which were there over a period of time. That is, one is oxidation. We already told you now that is a low cost treatment which was there for a very long time. And rotating biological RBC is another. Baffled septic tanks, wastewater sublation ponds, which I have also discussed, soil biotechnology, activated sludge processes, trickling filters, fluidized aerated bed reactors, upflow anaerobic sludge blankets. So these are the conventional plants which are already there from last few decades. But we are also looking at the recent ones which are now in the which are now more effective and producing the better quality of effluent and also taking less of energy. So these are the other plants that we are looking at. We are so much plants in the SBR. Sequence batch reactor is there in Bangalore. We have many, and also in many other in India. More than hundreds of plants are in SBR. In the last few years, this sequence batch reactor is coming in a big way. Coming back in a membrane bioreactor, perhaps. If people have gone to Cubbon Park, you must have seen the treatment plants there, MBR, membrane bioreactor, which takes only 25% of the conventional treatment plant and produces a high quality of water. You can drink that water. That is the level of at which the membrane bioreactor, because we are using a membrane there. That is one of the, I will show you some of those slides. Membrane aerated biofilm reactor, MEBR. This is the latest technology. From only last 5 years, this has come. A few plants are already there in China, some in USA. I think this is another plant where nitrogen can be removed, almost 90% of energy can be reduced, etc. Moving back to MBBR, you can also see some of the plants in many of in Bangalore city. I told you that the 2,600 sewage treatment plant, decentralized sewage in MBBR is very much used in decentralized sewage treatment plant. MBR is used. So now you can Bio4. This is a patented technology from a company from France. High rate activated sludge process Bio4, which you have in VISVESVARAYA sewage treatment plant. Submerged aeration fixed film SAFF is also fixed bed biofilm activated sludge process FBAS, and ring flow sludge suction clarifier. And see, these are some of the latest technologies, out of which up to this submerged aeration fixed film, these plants are coming up in a big way. So I think, see, if I go on talking about these things, I think it will take more than 2 hours. I think I will go a little fast. You can get my my presentation who are interested. And basically what I'm
also there is just for the information, sir, actually YouTube is going parallel. YouTube, your lecture is there. YouTube link will be shared to everybody. Parallelly, there is a viewers of YouTube.
So because see, basically these, if I go on explaining each one of them, it will take a lot of work, but I'll only tell the glimpses and see, we'll go forward. Is it okay? So this is the main stabilization points are there for a period of time. As I told you, this requires large area of land. Anaerobic ponds are anaerobic ponds, facultative ponds, and mensuration ponds. So these ponds, these are all anaerobic pond, deep ponds, because you see the sludge is settled there, and thereby it needs no aeration. This is raw subject which is treated in anaerobic bacteria. I think that is most important. So here facultative ponds as a shallower place where aerobic ponds consists of aerobic zone. This you can see here. See, this is a large quantity, large area is treated with surface water, and this is a facultative point. And mensuration points is a combination of both large and surface area and anaerobic process. These are the three type of processes that are, see, in most of the old treatment plants in urban areas, pre-urban areas, you can see that, for example, Kolar, if you go to Kolar or Tumkur or many other places, so they have adopted only this waste stabilization plants. I think these are all, only the point is they require more land, and it doesn't require these advantages. I'm going to tell you advantages: low cost, low maintenance, etc., and appropriate for, can be used for various type of concentrations. And the municipal, if you could see the disadvantages, large lands are required, especially for mensuration plant, hence not suitable for large urban areas. Urban areas in the sense, basically, I'm talking about class 1 city and also metros. It is very difficult to get this type of land. So waste stabilization combined with aquaculture, like duckweed, waste for hyacinth, etc. So as well providing additional treatment for them. This is the oxidation ditch, which you can see in ISRO. It was constructed as early as 1970s, late 70s. Type of activated process with long solid retention time. This is a high retention. It is nothing but a extended aeration. These are the most appropriate small communities. I think this is these oxidation discs are still there in many places. Are advantages and disadvantages. Ability to achieve receiving water quality objective with low operation maintenance cost, low hydraulic retention. I think this can be suitable for rural and peri-urban areas, and extended time or less mechanically intensive areas. Relatively simple to operate, but more complex than wastewater stabilization plant. Now, this is a plant where recently it has taken shape. From last, 10 years, I think 10 or 12 years, this has taken this soil bioreactor, SBR, has taken a very big shape. And one of my friends from IIT, Shankar, Professor Shankar, has invented this, and see, he has this. There are a number of plants in many parts of the country. I think this is a very simple and doesn't have the advantages are many. It consumes less energy compared to conventional technology, and fluctuating roads and complete water treatment happens. The output quality is comparable to very high standard international standard, etc., etc. No smell, no odor, no skilled labor required, etc. So this SBR is also one of the plants which was installed in Bangalore, in Mumbai, and many places in around. I think you can just go to the Google and you can find out number of places these have been installed. Now coming back to rotating biological contact, RBC is a old technology. This also will be applicable only for small treatment facilities. Consistent disc, you can see the disc here, which will partially get into the sewage and coming out, and see the microbes will get oxygen from when it comes to the atmosphere, and this will go on rotating very slow rotation. These are partially immersed in wastewater, rotate slowly and allow active bacteria to digest, etc. And these are all, there were many plants earlier, even in developed countries also, small plants still exist. This RBC is also famous in many areas. This disc filter, I think the same RBC, and with different, I mean, you can see these are changed the system, the configurations, and they have done a better system. So now coming to baffled reactors, I think this baffled reactor this is nothing but a baffled reactor. Many, even in Bangalore, you can see it's a number of layouts they are using this baffled septic tanks. I think it will pass through several small chambers, and ultimately when it reaches to the 5th or 6th chamber, the quality of water is so fine that the quality will be equal to the acceptable standards to live into the stream. I think the treatment performance, I think if I go back, I think treatment performance is lower during 3 months startup, phase when in 3 months means because they have to settle down, and this sewage has to, I mean, settle, and then it has to overflow to the next chamber, and then next chamber. This takes a while, creating a sludge blanket. I think that's very important. Advantages are suitable for wastewater, including domestic, small community, isolated settlements. So you can see in Mysore Road, there are, I have seen three or four plants of this thing. They are getting, this water is being used for non-potable uses for agriculture, car washing, etc. So the limitations of this is upflow velocity should never be more than 2 meters per hour, and the limited upstream velocity results in large but shallow tanks, and therefore it is not economical for larger plants. So small plants where up to 5 million liters per capacity can definitely be used this. So coming back, see, next is most importantly, as I told you, just a few years back, they have come this activist process. They have celebrated the centenary, and this wastewater ASP plant are there in Bangalore, many, and one of them in KNC Valley. You can see both KNC Valley activist process of 218 MLD and also 60 MLD plant with extended aeration, etc. I think wastewater rigorously increase dissolved oxygen concentration. We can have a diffused aeration as well as surface aeration, and these are all can go up to 95% removal of BOD and COD, and this is one of the best well managed, and ultimately this activist-led process, the sludge can be recovered and can be utilized for digester, and we can get say the gases what is required. I think sludge digestion can be done through digestion. Sludge production depends on the sludge retention time. So basically, when we are in extended aeration, it is much more. It's almost 12 to 18 hours. But here in conventional activated process, it is 6 to 8 hours. So this is a very aptly used over a period of time. Several countries around the world, in India also. Now there is a change in the shift. I think this is a operation. The secondary sludge being recycled. 50% of the sludge has to be recycled into biological process because of the need bacteria to reduce your organic load. So continuous supply of oxygen sludge are essential. Therefore, regular maintenance is also required. Limitations are highly competent, trained supervisors are necessary to maintain this whether surface aeration or diffused aeration, and high energy consumption. So recurring costs, performance is affected due to interruption of power supply. Yes, in Indian scenario, we are now things are slightly better. We are going for our own captive power, etc. And today things are much better than what it was. So activated process involves rapid mixing of variation. I think I would like to. So this is another trickling filter is much earlier than your activated process. See, this is an attached growth. I think we are the previous one is one are suspended growth. Here is an attached growth. The sewage you can see here is sprinkled on the whether it is a rock. The medias can be whether it can be a basically granite, or it can be it can also be plastic media, etc. I think the wastewater which is sprinkled on that, so with the available organic matter, there will be growth on the granite or this one plastic media, and that will will reduce the organic load, and the wastewater is treated. So this is one of the old treatment plant process technology, but only point is it requires a large area compared to say activated process, etc. I think that's why this is not being recommended in many places, but definitely it is one of the important processes involved over a period of time. It is possibly as a post-treatment of operation of USP plant. This can also be used depending upon the availability of land. Trickling filter operation, rotating. I think you can see the So limitations, some of the common problems: increased growth of biofilm, improper design, changing of wastewater characteristics, equipment failure, mechanical breakdown, distribution arm, blockage of due to excess biomass, etc. So these are some of the problems that are associated in the trickling filters. And most importantly, flies, filter flies, that is called Secoda. See, caused by inadequate filter media, moisture can be a nuisance. So here you can see a lot of Secoda. See, when we installed it in close to Rajeshwari Nagar, we have seen this plant. This flies, filter flies are one of the common, and there was a lot of complaint from the neighboring people who are residing, and that is where this is also causing a lot of problem. So, but see, this can take shock loads, and that can work, but the quality of final effluent quality will not be matched with the activated sludge process. It can go up to only to 90% of say BOD reduction. So this is another technology. See, after 90s, many plants were installed under say around Delhi and many other parts. Even now, see in Bangalore also we have installed say 2 plants earlier. USP followed by activated sludge process. I think USP is upward anaerobic sludge blanket. Basically, this works for a small plants, and secondly with a high BOD load, so or COD load. I think he had to create a sludge blanket, which is very important here, and only then this see there will be gas generation, which can also be recovered and converted into say methane. I say it can be utilized. The methane can be utilized for the but unfortunately, this creation of a sludge blanket itself is it takes a while, and see the quality of final effluent coming out of this USP needs further treatment, which is going to be only 60 to 70% of BOD removal. And if we have to go up to 90%, 95% removal, then we have to go to additional treatment process, which is a biological process, and that is where see we have such plants, 2 plants, and later on I think we are not built any. So 10 MLD plants, small capacity plants, have been installed one in Kyarpuram and Nagasamira. So these are the limitations: careful monitoring and control of sludge reactors, frequent cleaning, desludging is also very necessary. Removal of scums, floating materials, flow rate is controlled, so the hydraulic and organic loading are to be balanced, mixing of industrial flow, etc. So that is about UASP plant. UASP plant are installed in under national NRCP. A lot of plants around Delhi, because they found this is a better thing. But now not much of the plants are there because of the fact that they cannot be effectively controlled. So this is the SBR plant. You can see number of plants today. SBR technology is being utilized. See in Bangalore now more than 5-6 plants you can see here. Apart from that, BD has constructed say 1 or 2 plants here. I think so. This is this can also remove nitrogen phosphorus to certain extent. That is one of the advantages. The 3rd degree treatment which we are looking at, so not against what is required, but it can remove to certain extent nitrogen and phosphorus, which is detrimental for say when nitrogen phosphorus they're there with the sunlight, so the lot of eutrophication takes place, the weed growth takes place. So nitrogen phosphorus elimination is very necessary when you are living into a lake or even to a water body. I think that is where SBR taking a much there are many plants. I think recently also I am told that I have a lot of report. Bangalore has 35 sewage treatment plants. Out of that, about 5 to 6 plants are SBR. So improved aesthetics there are not required as separate. Even private, I see BL has connected one SBR plant recently, 10 MLD, and see the even see the some of the corporates have constructed SBR plant, 5 MLD, etc. So this is a good process. I think SBR is now sequence batch reactor is a very simple technology. So the only disadvantage of this is no provision for sludge management, no provision for primary treatment, and so this will be an advantage actually. No provision for primary treatment. High energy is put in use for the biomethanization. Requires at least semi-skilled manpower. Patterns of process technology in this decanter define local calibration. So these are the type of the media which are used in say MBBR and aerobic bioreactor. So this is again. So this is I think biofilm process. I think this is another process where each country produces a different type of these biofilms, plastic biofilms, and they are put in an aerobic tank, and they in turn organic matter is again stick onto this, and gradually that will be we are the slough off. MBBR, this is MBBR fluidized air moving bed bioreactor. MBBR is also there. Many plants in India and many plants in Bangalore. If you look at various industrial areas, I think MBBR is very much used. And as I told you, out of 2,600 plants in Bangalore, small capacity plants, I think almost 25% are MBBR plants. So this again using the plastic media inside and the upper. This is a bioreactor, MBR. I told you, now MBR is there in Kaban Park, and Infosys has also installed both in Mysore and Bangalore. This MBR plant is produces a very high quality of water. So only thing is, the primary treatment which screens are very low capacity, removes most of the screening things and directly gets into the aeration chamber, where it is with the high level of MLS's concentration of 8,000 to 10,000 we have to create, and then so that water is of aeration will be put into the bioreactor, where this ultrafiltration or microfiltration can basically ultrafiltration is provided, and this water coming out of this ultrafiltration will be of a very high quality. I say even turbidity levels less than 1 NTU. So you can visit this plant in because recently in Kaban Park, what it was 1.5 MLD has been enhanced to 4 MLD. So this we made it a bigger plant. This water is now supplied to Kaban Park, Vidhan Sauda, Rajbhavan, and also other adjoining places, because the demand was more, and we have enhanced the capacity of the plant from 1.5 to 4 MLD. Just now it is completed, and they are working for 4 MLD. This is a very interesting plant, and there are umpteen number of these MBR plants are there in around the world, and now very few in India. But now they are. If you want really high quality of water, this technology can be used very much. It takes only 25% of the conventional technology, the area required. So this is major. Of course, disadvantages are each vendor advocates. Basically, I'm going to discuss on membranes. See, there are 4 types of membranes: microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. These are the 4 type of membranes which are used in treating this water. And that here in membrane, in the MBR, we are using mainly ultrafiltration. So vendor, there are many vendors now who advocate that one is a big one and all that. It is not possible to cannibalize the system between different manufacturers. High resilience and energy, of course, it is energy intensive, because we have to see that this MLS's concentration of aeration should go very high. Patented process technology and decanters define cannibalization. Detailed evaluation is required. Probably in the next few years, this can compete with the conventional technology. And definitely, this is the membrane technology. Membranes cost are coming down. Energy, we can see anaerobic digestion. If you do that, the energy can be reduced, energy can be recovered. And with that, see, this anaerobic MBR plants are going to be cheaper than the conventional technology. So case studies, I told you, 4 MND of capacity plant in India, meeting horticulture requirement in Vidhanasabha, Rajbhavan, etc. 2 number of 0.5 MND in IISc, which I was the advisor for IISc, and we have provided 2 plants. And see, today they are meeting all the requirement of their non-portable usages. Infosys has 3 MND plants, Mysore and Bangalore campus. So these are the plants close by which you can see them. So this is exactly what I wanted to show. The membrane pores. See, if you look at this, I think the microfiltration has 0.1 nanometer of this particles can pass through. 0.001 is ultrafiltered. 0.0001, 0.301 in the RO can remove entire chemicals before it gets comes out of from the reverse osmosis. I think that is where reverse osmosis water is completely divided with all chemicals. Chemicals are required for human beings, but unfortunately with reverse osmosis, see, that entire chemicals will be removed. Now what they are trying to do is they are injecting several chemicals in order to make sure that the drinking water gets, for example, right from organic matter as well as to the basically I see we need certain kind of fluoride, we need certain kinds of calcium, we need certain amount of magnesium, etc., etc. But everything is removed in reverse osmosis. That is one of the drawback. Even the world WHO also doesn't recommend to drink water with reverse osmosis. So these are the type of hollow fibers which you can see. I think this is ultrafilter, US filters. These are the type of filters, ultrafiltration. This small scale, this thing, and this is a Mitsubishi. The different companies. Memcor is there, Mitsubishi is there, Asahi is there, Coach is there. This is the Puron in this meter, tubular meters. Flat. This is the only company makes in Japan. Flat plates, Kubota. So Coach, and so these are the companies which make. I think the representatives are there in India for all these companies which are producing over a period of more than 2 to 3 decades. This is anaerobic MBR concept. If it comes through, it is under lot of research, and finally, if it comes through, it will definitely will be easier, cheaper than conventional technologies, and it requires only 25% of this. So membrane aerated biofilm reactor. This is the latest from last 10 years only. So this is this plant is something you can see here. Energy efficiency, wastewater treatment is reduced by 90% less energy than the conventional. Effluent quality, which also removes nitrogen, phosphorus. So in a way, this is going to be also going to be. There are only a few plants in China and USA, but probably here we are also trying to bring it here into India, in Bangalore also. MABR is going to be the best technology. I think this is the details of that. You can see features, benefits, etc., etc. I think these are the case studies of MABR. This is the biological filtration oxygenated reactor. I think we are getting running out of time. Can you play that video?
Thank you for you have almost taken more than 1.5 hours. You are not exhausted. You are all highly energetic persons. You have shared a lot of information technology. Now I request Sanat Kumar. You can play the video.
Yes, sir. Yes, sir.
Regarding water, then sir can take the last 15 to 20 minutes. Sir.
Okay.
Yeah. As I request participants to send the questions in chat box, because it will be another half an hour, 45 minutes lecture will be there. Please post your questions in the chat box. to get the gold, black gold, sir has mentioned, revenue generation.
Sir, audio is available?
Yeah.
No. It's only music.
Sir,
Only music, correct. It is there.
Yes, sir. Okay.
Okay. These all things can be removed by preparing technology. That's it.
Yeah, very excellent video, sir. It is a lot of information you are shared to everybody. They will carry in memory. They will not forget this video. They know what is the precious of water and what is the use, how to reuse, recycle all these things. I think this will be available with the YouTube also. If required, we'll share all the participants. Now, sir is going to share another video, very important. See what is the revenue generation from the wastewater. So far, you have seen only the what are the various methods of wastewater treatment. It may be suitable to all the types of cities, metros, and municipal everything. So please share, sir, your video. No issue, sir. Next PPT.
Okay.
Please keep going sharing, sir. Then I'll conclude mine. So the next presentation, it will take another 30 minutes only. I think sir is going to give the what is the revenue you can generate from the wastewater. Therefore, sir has introduced wastewater as a black gold at the beginning of his talk. So now how this black gold, you will get some lot of money generation. Now I will. And also welcome Director Srinivas Kulkarni, sir. He has joined because was held up in meeting.
Actually,
welcome you, sir.
Good evening, sir. Good evening, sir.
Yeah, I think
evening.
your video is not seen, sir.
Yes, sir. I'm traveling, sir. Actually.
Okay, no issue. Okay.
I'm traveling, sir.
Okay.
Actually, this evaluation of treatment process, these are the factors which should be considered. These are the various technologies, process technologies that are. So this is also very interesting. I think people can look at that.
See, all Nirmiti Kendra engineers, whenever you are preparing an estimation for any wastewater treatment, think of what sir is going to present. It will be highly useful. I request all the project directors and the Nirmiti Kendra engineers, other interesting people. See, actually, the wastewater is not a waste. You can generate some income from the wastewater.
Screen share at the bottom, sir. Yeah, at the bottom screen share.
I am not getting the bottom. That's the.
At the bottom. Yeah.
Oh.
Just move your cursor. It will display.
So wonderful session, sir. I think he's going to.
That needs 3 hours, sir. Actually, we have given 2 hours. Sir told a lot of time is required.
Yes, sir. Yes, sir.
Therefore, just I'm requesting to wind up in 30 minutes. We will have one offline, sir. Next, we'll have one workshop or one the skill importing only with respect to wastewater management techniques only, sir, for all types of engineers. The sir has to close the first slide, first PPT.
He is searching. I think
Okay.
he is not getting the PPT or something.
Okay.
Sir, what happened?
No, actually, see, I am not getting the
PPT.
Not PPT. I think this border.
Okay, 1 second, sir. 1 second.
Sir, you don't have to, sir.
Tools, yes.
No, 1 minute, sir. I'll make this one. Sir, now you check, sir.
Okay. Now I think I should get that.
Yes. Yes, sir. Okay. So click on, yeah. Yes, sir.
We are able to see, sir. You can go for full screen.
What I'll do is,
Okay. You can present with this one, sir. We are able to, good, sir. Yeah, it is.
I'll take another 25 minutes.
Thank you, sir. Thank you.
Basically, I don't want to too much of burden.
Okay.
See, this is exactly, see, wastewater resource in circular economy. I think this is basically what I want, resource recovery. I think resource recovery and recovery of untapped resources of wastewater. This is my real presentation. People will have to really look into this very, very aptly, because without this, in the days to come, there cannot be sustainability. So whatever say the UN has said, so wastewater resource recovery is a must in the days to come. So in that context, see, in the world, water where demands of fresh water are continuously growing, demand for continuous requirement of fresh water, where limited water resources are increasingly stressed for over abstraction, particularly groundwater, surface water, and etc. Over abstraction of groundwater, pollution, and climate change, neglecting the opportunities arising from the improved wastewater management, nothing less than unthinkable in the context of circular economy. So, what is linear economy? What is circular economy? All that we are going to discuss. So resources are becoming scarce, therefore reuse water resources becoming more and more attractive. Wastewater can be used as a resource since it contains many resources of organic matter, phosphorus, nitrogen, heavy metals, thermal energy, etc. In the face of ever-growing demand, wastewater is gaining momentum as a reliable alternate resources of water, shifting paradigm to wastewater management from treatment and disposal to reuse, recycle, and resource recovery. This is 4R, what I am going to say. Wastewater can also be cost efficient and a sustainable source for energy, nutrient, and organic matter, which I am going to show you all these things in the next few slides. So what most important thing is wastewater is roughly composed of 99% of fresh water, only 1% of suspended pollutants like colloidal, dissolved oil, etc., etc. Although the exact composition of wastewater obviously varies between different, because industrial water there may be different, but we are talking about municipal water, 99% is the fresh water, 1% is only see the pollutant. So this pollutant, if we can remove, it will become 100% again fresh water. I think exactly what you are seeing in the your video. So most human activities are say use water, produce wastewater. I think we are all producing water, use water, and we produce wastewater. I think all our demands of water grows and quantity of wastewater produced, and it's all over pollution and load are continuously increasing worldwide. We already told you that worldwide there is pollution, 80% pollution is still there because we are not treating the wastewater. In the face of ever-growing demand, wastewater gaining momentum as a reliable alternative resource, shifting a paradigm to wastewater management from different treatment and disposal to reuse, recycle, and recovery. So wastewater can also be a cost-efficient and sustainable source for energy. So what is most important is in the days to come, by 2030, this is a UN report, 30% of more water is required for the entire world, 40% of more energy is required, 50% of more food is required. So for all these things, see, water is the original. I think without water, there cannot be any energy. Without food, without water, there cannot be food. They are all in nexus. Water, energy, and food are in nexus. So you can see here, of course, renewable energy is going to be one of the very important factor, and renewable energy can also be made from wastewater. So what we are talking about, integrated urban water management. I think all the concept is, see, in last 2 decades or 3 decades back, see, all forms of water, potable, wastewater, potable water from these sustainable sources like, see, your storm water, rainwater, all these see, surface water, groundwater, all together, they form the surface water. And see, wastewater is, see, again, so grey water, recycled water, etc. They are from wastewater. And Starum water, he has basically a Starum water quality improvement and all these things. These things should improve. I think if we can use all these forms of water, I think we can become sustainable. So, but the higher version of this integrated urban water management, we are looking one water concept. In one water concept, same thing with additional, the infrastructure improvement, drinking water quality, etc., all have been built. So we are looking for one water concept, that is entire water, whether it is in the form of groundwater, whether it is in the form of surface water, whether it is in the form of wastewater, whether it is Starum water, whether it is in the form of ocean water. All these have to be integrated if you have to really sustain in the days to come. Because mainly, see, 7.8 billion people are there now. By 2050, it is going to be almost equal to 10 billion people. So where is that? See, this is exactly what is happening. Cities are growing and we need water. And see, every agriculture, we need more food, we need more electricity, etc. So these are the different sources. I think what we have discussed: river, dam, and seawater, and domestic wastewater. That is the wastewater which we had from the municipal wastewater, industrial wastewater, and Starum water. What all these things can be converted? River water, dam water, directly you can for drinking purpose. You can, so the domestic wastewater can be converted for drinking purpose. I will show you some slide where now many cities are already having a city for drinking water, and that can also go for non-potable purposes for industrial requirement, etc. So then that can also go for industrial users, and industrial water can also go directly into industrial users. Together, the Starum water is again most importantly. See, we are not giving much attention to Starum water. We are only thinking of flooding of this thing and all that. But this water should be saved in order to see that aquifer recharging. It can be used for drinking purpose. It can be used for non-potable purpose. It can also be used for industrial purposes and also lastly irrigation. So Starum water is given a raw deal as in today. See, there are now many types of low impact development processes, green infrastructure, and China has come up with what is called smart cities. So these are all something which we have to really do if we have to really contain using this Starum water and all forms of water. Less than half of wastewater global collected, even say 80% is still, this is exactly what it is, 20% only treated, 80% is not treated, etc. I think I'll shift this and so this picture gives you, see, this is wastewater coming from domestic houses, industries, and also from big condominiums, a wastewater treatment plant. This wastewater can be treated and used for various these purposes. This is exactly what I'm trying to. This sludge can be converted into biogas, in biosolids can be converted into big, the fertilizer, and phosphorus recovery is another one. So if you really use this water properly, I think this water can be sold after treating. This has a cost. And today Bangalore is supplying at 25 rupees per kiloliter of water to non-industries along Yelahanka. Perhaps Nagarjuna is taking water, and I don't know, Yelahanka treatment plant we are supplying. From there, we are supplying to wheel and axle, we are supplying to airport, we are supplying to Air Force, we are supplying to so many. So we can recover that water at the cost. Similarly, you can recover energy. So today, Bangalore can self-sustain with the energy for running of the plants. We can recover the phosphorus, which is very, very important. This is a very costly thing. I think today, phosphorus is only getting only 3 or 4 countries in the world. So now there is a shortage of phosphorus everywhere. And in the last 1 decade, there is more than 600 times increase in phosphorus recovery. So from wastewater, we can recover phosphorus. I will show you some of the slides, how it is being done. So it is 80% of the wastewater is not still treated. It should be treated as the most important resource recovery. So in the process, we can, as I said just now, recovery of water is one of the very important thing. Recovery of digester gas from where it can be converted into energy, into CNG, LNG, etc. And nutrient recovery of phosphorus. So this is a slide shows you how the energy can be recovered, biosolids can be recovered, etc. So this is a paradigm shift. Consider that most of us material can be recovered for this thing. I think this is a renewable source from where I told you water can be recovered, energy can be recovered, nutrients can be recovered. This is a resource recovery. So in the process, what we are going to get by selling this biogas of our electricity, sale of carbon credit, you can get tipping fees. I think today, see, all this food waste is collected. Food waste is collected and they are getting fee from the, particularly from the public. And that will co-generation is done and thereby generating more power, generating more gas and more power. And thereby they are not only feeding the entire treatment plant, but also they are feeding back into the grid and making money. This co-digestion which you are showing here, I think is from F4G, fat, oil and grease, and as well as food products. They are going to create a lot of additional power, additional biogas, and that in turn will be converted as a CNG or LNG, which will make a lot of money. Savings, using own generated electricity, you are going to save money. Revenues can be treated wastewater, as I told you. See, I have just now seen in Surat, they are selling at 30 rupees per kiloliter of treated water. I think many places in fact in Chennai, they are long back they are supplying to Madras refineries and Madras fertilizers. Now it's supplied at a cost of 40 rupees per kiloliter, and they are treating with and using for that. You can also save in discharge fees. You can also save in the sale of phosphorus. As I told you, phosphorus is a fertilizer where you are virtually phosphorus is not available in many countries. It's a very scarce resource. We can recover this resource from the biosolids. So with that, I think what I am trying to say is circular economy. Circular economy, what is, what we are resource is being used and ultimately water is discharged. I think you are not recovering this water. After treatment, you are only discharging into the river. Instead, you can say production, distribution, consumption, and resource recovery and recycling. So thereby you will get this waste, not only you will get water, but also the biosolids, etc. And you can make money. So with all this, it can be a profitable job rather than a burden on the institution. I think for that you have to spend little, but the governments can support these sort of things. Circular economy is most important because water is a scarce commodity. I think in days to come, we have to seriously look at to circular economy. I think this is exactly what circular economy in industrial is a regenerative or intention and design. It is economic system aimed at minimizing waste and making most of the resources. Traditional approach is based on linear economy with a make, use and dispose. This is make, use and dispose. Modern production, the circular economy approaches replaces the end of life concept with restoration, shifts towards the use of renewable energy, eliminates and the use of toxic chemicals, etc. So we are looking recovering this wastewater, which is going as 80% waste. That should be so. This is wastewater is yet an untapped resource in India. I think we should seriously look at how we can this actually self-treated water industry, commercial and complexes, and realize this has been done in Bangalore. I will show you one slide. Recently, it has come in the Times of India. One of the condominiums they are treating to the high standard with RO and selling it to the neighboring industry at a cost, and they are making money. So realize entire maintenance of treatment plant of O&M and similar to many plants in Mexico, South Africa, and etc., Brazil, etc. General electricity self-consumption and save energy. I think I showed you last slide similar to phosphorus recovery. This is exactly what we are thinking of. And water reuse is economically feasible and attractive when there is a potential for cost recovery in treating wastewater to water quality standards acceptable to users. So this is exactly what I want to show you. And the 4 R's which are reduce, making wastewater, removing the pollutants, reusing this water, and recovering the untapped resources like energy, etc. These 4 R's are the burden. Wastewater is not a burden, but it's a valuable resource. That is why they call it the black gold. So in the sense, the prevention of reduction of pollution at the source, when you are reducing the pollution, automatically the wastewater produced will be prohibiting this thing. Removal of contaminants in wastewater streams. This should be done in the operational systems. The use of wastewater and the water reuse, safe and treated and untreated wastewater under controlled condition, beneficial purpose, historically used for primarily for irrigation. Wastewater treatment technologies now advanced allow the use of treated wastewater for all users, provided that the level of treatment and quality of effluent are fit for purpose. I think you have seen the video which can clearly tell you, you can use it for all four purposes. One is agriculture, second is for urban use, third is for industrial usage, fourth is for portable reuse. So, and these are the, and lastly, the recovery of useful byproducts. I told you that the biogas, sludge, and biofuel for microalgae. These are some of the very important this thing. The first one is reducing and prevention of pollution of source. Pollution of prevention and the minimization of wastewater flow is the one. We should not throw out all sorts of things into the wastewater. And this is again a treatment of wastewater where, see, you get a clear water and the byproducts of biosolids, nutrient, and biofarm, unrecovered waste residuals, and the energy. I think we can convert. I told you about how methane can be converted to energy. And for treating this water, we use chemicals and these are the gases which are coming out. For treating this wastewater, we need to have energy, chemicals, and labor. So this is a total approach. I think these are the benefits of, even carbon dioxide, hydrogen sulfide, methane. This is a maximum 67 to 70% of methane is generated, and we can increase that by adding cogeneration. So these are the byproducts, biosolids, nutrient, biopolymers, etc. I think this is from the collection point of view, this is something very important. This is the sewerage system encompasses these two things. One is conveyance system, and this is the treatment process. So if we can do that, and see, as I told you, centralized versus decentralized. See, earlier, prior to 1960s, we are only going for centralized, taking away the entire sewage out of the city because it is creating a lot of nuisance and all that. And decentralized plants are smaller capacity plants, which can be maximum over 20 to 30 or even up to 30 MLD. These plants are very much there, and we are using various type of technologies which will give you a very beneficial of reusing that water, and also can be used for various other untapped resources. So sewage treatment plants and water factories achieve millennium goal, the treatment of recycle and reuse, high quality of reuse water for all applications. What are those applications? Industrial applications, agriculture usage, groundwater recharge. So even groundwater recharge, I have seen many plants in Australia and California, in California state, where the water is in the confined aquifer, they are putting back highly treated water, and after some time they recover and use it for drinking purpose. See, this is managed aquifer recharge, MAG. So urban reuse, you can use it for various, for golf courses, for gardens, car washing, whatnot. So you can use it for most of the purposes in urban area. We can. So lastly, this water urban usage, you can also go for for reuse of water for drinking purpose, which I will show you. So what are some of the cases in other part of the world? 32 billion gallons of water, municipal wastewater effluent discharged in the US, roughly 7.3% is reclaimed, and now it is going to be very high. I will show you some of them. Israel uses more than 85% of wastewater, and today they are the pioneers in agriculture usage. And entire wastewater, almost by end of this decade, I think they'll go up to 90% of water reuse, for that water used for agriculture. Singapore uses 35% of their wastewater for drinking purpose, and that will go up to another 15% by 2040. So Australia now uses 20%, has national goal of 30% by 2020. Spain recycles more than 15%. So USA has many big projects. I will show you that one slide. More than 180 plants of for drinking purpose they are going for this. So even projects in Florida, California, Arizona, Texas, and Nevada, They are going for indirect and direct potable use. What is direct and indirect potable use? I will show you it in the next slide. See, this is a planned direct, indirect potable use. What is doing in Singapore? What is doing in what they have done in Brisbane? What they are doing in many parts of the world? I think this is indirect potable use. The stream which is going, river which is going, they are off taking for drinking purpose, and this lake they are treating, taking, and they are treating a wastewater drinking water treatment plant and supplying to the city, and the wastewater generated is treated to the high standard, and they again put back into the same lake. So again this is treated and supplied. This is called indirect potable reuse. So people will not be objecting because they don't feel that we are directly using this water for drinking purpose. See, here is a case where, see, this is a wastewater is directly, see here they are taking water from the river and they are using for treating this water and putting back into this system, distribution system. Again, the wastewater is treated to the high standards. You can see here, and that water again put back into distribution. See here they are put back into the aquifer, again treating, and again here it is not so. After treating these high standards, this is again put back into distribution. So this is a Singapore case where this indirect potable reuse is being done. It is put back into the lake and they are again treating and using that. So here is a case of direct potable reuse. In Windhoek, in Namibia, which is the capital of Namibia, they are using water from last 53 years, 54 years actually. See, direct potable reuse. They don't have any resource from more than 800 kilometers. They decided to go for direct potable reuse, and this has completed 50 years. A celebration was happened recently. A big celebrations of 50 years of was happened, and another 21 MLD plant was constructed. A direct potable reuse. So they are not treating or putting back into the lake because they don't have any lake or they don't have any surface water resources. So they are only blending it some quantity of groundwater and using it for drinking purpose. See, this is an example for us how people have to realize that that they have to think of this. This is a case of a Singapore where the 4 taps are there. One is they have getting some water from Singapore according to service, but they have reduced their supply of water from Singapore, which was originally supposed to. That is tap 1. Second tap is from the wastewater which is generated. They are 35%. They are treating and bring it. The third tap is from the desalination from the seawater. The fourth tap represents the storm water that is put back into the lakes are being treated and supplied. So this represents 4 taps for getting 1,500 million liters of water to Singapore. So we are banking on Kaveri only in Bangalore for 1,450 million liters. But they have these 4 taps which are supplying and making them sustainable. This is a case of Australia where, see, Western Corridor project or Brisbane project where Australia, Queensland, 232 MND plant was installed, taking 3 sewage treatment plants, sewage, and under this dam, they are supplying water to the 200 kilometers length of pipeline was laid. It is a costing about $2.5 billion Australian dollars, and these are the 3 sewage treatment plants from where the sewage is collected and treated with advanced technology, microfiltration followed by reverse osmosis. This is the plant where, so these are the 3 sewage treatment plants which are and they are supplying to some of the power projects as well as the drinking purpose, putting back into the aquifer, indirect potable reuse. So now Santiago is spearheaded, and history makes by 2014 will probably go down in the landmark year when the direct potable reuse took place in US. So this is a 300 million liters. It's a very big project. It's a direct potable reuse it has been done in Santiago, and similarly in Texas. The DPR, direct potable reuse, and you can go for aquifer recharge. This I have seen in Orlando, 202 plants of recycled plants. They are putting back into the aquifer. They also grow orange garden. Together they are putting back into the aquifer and again taking back and using for drinking purpose. So there are many such plants, groundwater recharge and using In California, there are there, and see, not only in Perth, there are 2 plants. So likewise, there are many plants. So new survey reveals California overwhelming support for recycled water as a long-term drought solution. So by 2035, they have said 100% of wastewater should be used for drinking purpose. This is the decision of Californians, particularly Los Angeles. This report, 89% of the residents are more willing to use recycled water after learning about the advanced technology, etc. Sacramento, etc., California. So this is Florida surpasses the largest market for water use. So this is again, perhaps many of you should be knowing Singapore, even in Japan, many various. This is in Japan, in Shinjuku, where all the entire house buildings, which are more than, I think Shinjuku has almost every building is more than 25 floors. So they're all using recycled water for toilet flushing and gardening. So reclaimed water. So there is also Rose Hill water. I think I have seen this in Australia, where Sydney, see the new housing project has recycled water plus fresh water. And this recycled water is used basically, see here it is fresh water coming from Warragamba Dam, which is supplying almost 90% of the Sydney, and the recycled water is supplying. So they have a separate two pipe and with the special taps outside for recycled water. And this will be used only for car washing, then used for toiletry flushing. Almost 40 to 50% is supplemented against fresh water usage. So this is a plant which I have recommended and which I have advised to Bangalore Indian Institute of Science, which is running from last almost 12 years. Recycled water is supplied to all the departments and also to the Jamkhana grounds, etc. They are very happy with the recycled water. This is exactly what can be done with the recycled water for non-potable use. Bangalore has, see, as I told you, Bangalore Golf Club, there is a 1 MLD plant. There is Lal Bagh, there is a 1.5 MLD plant. Karnataka Golf Club. Apart from this, I told you there are 2,600 plants in various capacities in different parts of it. We are also, Bangalore also embarked on one indirect potable reuse from Vrishabhavati Valley, where 150 MLD of water can be tapped and treated to the high standard, put back into the Arkavati river course, where Thippeswamy is completely stopped getting water from last more than 2 to 3 decades. And with that, if we can mix up this treated wastewater to this, and we can again treat it and supply it to people. This indirect potable reuse project is on the anvil, and probably the government should seriously think of implementing this project, because we are short of water in Bangalore. As I told you, see, these are all the indirect and direct potable plants, 180 plants. You can see here, all along every plant, because this south of North America is a very burdened. I think they are facing a tremendous shortage of water, except these areas, particularly because there are 5 lakes, Michigan, Eric, so these can get water from these lakes, but whereas these are the places where there are tremendous shortage in Florida, Texas, California, Nevada, Arizona, etc. I think everyone is going for indirect potable reuse and direct potable reuse. So this is celebrations which I told you, 50th anniversary of Vinhat, where they recently completed 2000. They are constructed in 2001. Now they completed 50 years, and 2 years back they completed 2018. 18 October, they have completed direct potable reuse. This is something very, very unique. So resource recovery. Third point is resource recovery. I think recovering those useful resources, which is again told you. I think today you can see from Korabangla Chalagatta Valley, the wastewater which is treated is supplying to Kolar area, where including Chikkaballapur and also the Kolar region. I think the lot of water, secondary treated effluent, is going and filling up 150 to 126 lakes in Kolar, where they are very, very happy, and they're now getting, their borewells are recharged and they're using for agriculture purpose, and the lakes are very well managed, etc. that is for agriculture use. I am only giving an example. There are hundreds of examples which I Australia, which are all parts of the world, they are using for this agriculture usage. This is a case of Nagpur, where the wastewater is complete 100% wastewater is now treated and used for power generation. I think this is another, after seeing our projects, see the present transport minister, see who came as a president of BJP, he immediately asked Nagpur people, because he resides in Nagpur, he asked them to immediately go and look at our projects, and then they did this, and this Nagpur plant is now getting 100% wastewater recycled and they are using for the power generation. So power generation is again biogas, is again a biomethane generation, etc. I think I should do. So this is again show you how this wastewater from the city can be recovered, wastewater treatment and wastewater biogas can be recovered, and where CNG and LNG can be created. There you can see here this the CNG can also have, similar to what say the running of a tractor, running of a car, etc. Even you can running it. So these steps will tell you in all these places biogas is converted into CNG and LNG and they are using it. So these are some of the examples where see 100% is what is called energy neutral and beyond. Beyond means that they are recovering, they are generating more power than what is required and putting back into the grid. The blue plains in see Washington. See, earlier I visited in 1998, they were not generating any power. Now, today they are generating 10 megawatts of power. So, see, there are 5 Valley Creek water, 85 MGD capacity in Birmingham, producing energy required for the plant. See, South Durham wastewater treatment produces 100% energy and sells for self-generation. And Starus wastewater treatment, Austria, also runs in energy neutral. That means 100% energy is recovered. And Durham wastewater plant at the energy neutral and supplemented 10% of the solar energy. So this is what is really required in absence of or unnecessary production. You can really, these are some. East Bay see, this is again East Bay Municipal Water District, California is now, see, Oakland, California produces twice the requirement and power required, and rest is exported to the required grid. EBMU, this is the California. This is they are generating double the one. This is beyond zero. Then you see wastewater treatment, Aarhus in Denmark produces 50% more than the requirement, and they are putting back into the local grid. So there are such plants in many parts of the world. Now we can also do that. But we have some plants. For example, Chennai produces, see, 7.5 crore kilowatt hour of power is produced, almost requiring meeting the 70% of requirement of running of the plant. So Bangalore is one plant, they are producing 1 megawatt of power. Niloti of the sewage treatment plant, New Delhi produces about, they are also trying to go for 100% production. So many more are in the construction stage. I think Indian scenario, we have to, this is the plant in Bangalore where 1 megawatt power plant is putting back. I think this is a 4 plants, Coimbatore, Nesupakkam, Vendangudi, and Kodambayur. These are the plants which produces a huge, and they are recovering almost 5.5 crores worth of power recovery, in the sense to that extent of money is recovered. So these are the phosphorus. I told you this is a very, very interesting, and the phosphorus recovery is also very important. I think phosphorus can pose a harmful threat to the infrastructure and the environment, causing problems and eutrophication in water bodies. So this you can recover, and this one plant in Chicago. See, this is a phosphorus recovery. This is called Stickney Water Reclamation Plant, which I see the more I have seen in Chicago, close to Chicago. I think this is recovering almost 10,000 tons of high value continuous release of fertilizer. So this phosphorus recovery in the form of steroid. So this is one of the very important valuable resources and making huge amount of money for the utility. This is another plant in a location is Ridgewood in New Jersey, USA. Co-digestion, they are running the entire plant without without any additional power from the grid. And this plant is now, this is on PPP, and Ringwood Green village. They are 19,000 meter cube of design flow, and the average. The main innovation is energy neutral retrofitting exactly benefit and the village. So villages are benefited with so many other things. No capital cost, no taxpayer, no savings are lower operating cost, lower sludge hauling cost, lower electricity cost, more resilient, not affected by electricity prices, etc. So this is a struvite which is recovered. I told you from Chicago sticky plant. I think there you can see how the phosphorus in the form of struvite crystal form is recovered 10,000 tons of crystal green annually. Phosphorus or non-renewable resources. See, in wastewater, this is another thing. This is a plant in Singapore where there are plants in Singapore, Germany and Netherlands, also in the similar plants where the wastewater is used for manufacturing beer. So this is a very interesting, and many places. I have two more slides which I have not put in here, but there are another 5 places. They are in Germany, Netherlands, and Europe. They are using wastewater for generating, I think, making beer. So this is you see, another thing is apart from Singapore. So this is agencies. OCWD is allowed a bottle highly purified recycled water handed out of the educational tool. Around 2,000 bottles of purified water. They call it as purified water. In Singapore, they call it as new water, which is used for drinking purpose. So this is bottles of purified recycled water hit the streets of Los Angeles. So Chennai, again, I think they are doing a lot of work in the use of wastewater and also recovering. So there are many projects are going on. In September 2020, they have inaugurated one plant which is published in 29th November 2020. And this water is 45 ml tertiary treatment plant recycled of wastewater for non-potable usage. This is another very interesting. This is one plant of 80 ml capacity where in Keynes, perhaps you must have heard of Keynes. Keynes is a place where every year regularly this this thing is happening. And there is a plant of 80 ml which is 100% carbon neutral, in the sense they are using only energy from solar energy. So, and 100% that they are not taking 1 unit of electricity from the grid. And you can see here on all their units, they have placed these solar panels. And this is the unique in the whole world where this capacity plant is there to run without any external electricity. So final message is, take home messages is what? Wastewater increasing worldwide, vast majority released without treatment. Affordable treatment options are available. Reliable, sustainable source of water. This is a reliable and sustainable source of water, wastewater. That is the most important. Sustainable source of energy, nutrient, other recovery byproducts have to be done. In circular economy, wastewater use and byproduct recovery can generate new business opportunity while helping the finances of sanitation services. The cost of people water management are outweighed. So by benefit in terms of human health. So essential achieving the 2030 agenda for sustainable development. Sustainable development, 17 parameters which UN has said, and if you can do all these things, you can easily achieve that. So this is my last slide. Thank you. Thank you very much.
Thank you very much, sir. You are given excellent information, need of the hour for all of us. See, actually, there are a lot of technologies you have shared. What are the various technologies we can adopt depending upon the population size also. And also you are given what are the recovery. See, generally, we thought wastewater is a waste. Now you given a message to all of us. Say what are the various materials you can recovery. The one is energy is very notable thing, and also the phosphorus, and also again the water, because you have mentioned municipal water is only having a 99% water and 1% polluted. So with lot of Your experience speaks, sir. Even after 35 years of service rendered to BWSSP, still you are in very active, and almost 17 years you are spent as a international consultant with respect to this. Hats off to you, sir. With this age, and you are almost taken 2 hours 15 minutes. Unbelievable. Even though we are all teachers, we are strained so much with that. But I'm thank you from the Skill Center on behalf of all the participants. My wholehearted thanks to you, sir, for spending your valuable time with us. And this PPT is not because this YouTube is there in the public domain, so it will be shared to all the participants, sir. Thank you once again for you, sir, for spending your valuable time with us. And also thank you, Sanat Kumar, with these things. Any questions are there we can take?
No, sir, no questions, sir.
Yeah. And also I request the participants to go for the feedback forms are given just for useful to our organizers. And also thank you very much, sir. Once again.
Okay. No problem. Thank you. I should thank you.
One personal is actually definite. I have visited Kaban Park in Iowa International Conference one conducted in Bangalore University. I personally visited, sir. Thank you once again to all of you.
Thank you.